Oh my God. Hello, everybody. Um, I'm really excited. It was supposed to be last year, the NodeTLV. We didn't miss a year, but it's basically 2 years since NodeTLV, so I'm really excited. And I'm going to talk about promises, if they'll get it. There we go. I'm going to talk about promises. Somebody said, what is there to talk about promises? I mean, we've been doing it for 6-7 years already, so what's the point? And I'll talk about it. But first, I want to talk about myself, because that is who I am. I'm old. Yeah. Thank you. This is from 1984. This is one of my first computers. My dad is here. He can say that. It's definitely that. I've been programming for 40 years. Basic, Pascal, C, C++, Java, Python. From each, I've learned something. Basic, well, you start with that. Pascal, I don't remember what I learned. It was so far away. C, I learned how to do the curly braces. C++, object-oriented programming. Java, garbage collection. Python, dynamic, my first dynamic language. Scala, well, not a lot, but I did learn that not having semicolons at the end of the sentence is great, at the end of statements. And Node.js today for like 8 years already. I've been programming JavaScript basically for 21 years. And I have to say, Node.js is the most productive environment I have ever used. And this is after 40 years. And the ecosystem is fabulous, really amazing. Okay. Back. Thank you for that. Okay, it's huge. That's the red line, NPM. The others are like trailing behind. It is a huge ecosystem. And while not a lot of it is quality packages, I mean, most of it is basically garbage. A lot of it is quality packages. And I've used Snyk Advisor. There are some people here from Snyk. Great job, great help for the community. It's a really great tool to find quality packages and compare them one against the other. And yes, it's full of crap. And we know the JavaScript haters and the naysayers. They'll say, well, it's a toy language used by bad developers. We've already heard about this. Everybody has. And I remember that sentiment. I was in the Army. That's, again, me. I was a computer programmer in the Army. And there was the real computers, the mini computers and the mainframes. And all I wanted to do was, program a PC. And they were like saying, what are you talking about? That's a toy. Okay? And the PC was a toy. It was fun. It was easy to program. And it was accessible, so lots of junior programmers like me flocked to it and wrote code for it. Until suddenly, mini computers and mainframes disappeared, and we were the most important thing in the world. So yeah, the NPM registry is really full of crap. And but Node.js and JavaScript are really fun to program and accessible. And lots of junior programmers like me, well, I wasn't junior back then, flocked to it and wrote stuff. And those junior programmers grew up, and they became you. Okay, they became you, and you built the NPM ecosystem. You built Node.js to make what it is today. So let's all celebrate by clapping our hands, because two amazing things are alive. JavaScript and Node.js. Hi, I'm Gil. As I said, I'm really old. I love testing code. I love packages and modularity and whatnot. I'm currently an architect at Round Forest. We build complex shopping sites designed to simplify your life. And obviously, we are hiring. So if you want to use promises like I'm showing here in the sides, come talk to me later. Okay, promises. Most developers today don't think a lot about them, really. They just await some function that returns a promise, and that's it. That's the extent that people today use promises, and that is a good thing. I mean, I remember promises, they were very complex, and callbacks, and you had to interface between them and all that. ugh. It's easy today, and this is great. But what happens behind the scenes of promises is mind-boggling. And I did have a talk about it in 2015. This is not that talk. It's not about how promises work and all that stuff. This is about how to use promises, how to use them in really interesting ways. And the funny thing is, while writing the code for those examples, I found out that I didn't use not even one .then or .catch, like the promise. I only used await and try catch and whatever. So that's amazing what we've gone through in the 6 years since promises entered Node.js. Well, maybe less. But we're going to learn some really cool patterns, so buckle up. Let's start. And remember, promises, like the Force, permeate the universe. So I'm going to use the Star Wars API as an example API. First of all, Noob asked me to say that if nobody has any room and doesn't want to stand, it's also live in Hall B. It's streaming live in Hall B if anybody wants to see. And because I'm using Star Wars, this is a Star Wars copyright, I have no connection with Star Wars. The images and stuff are the sole and exclusive property of Lucasfilm Limited. Let's hope that helps. Okay, and this is my small wrapper around Star Wars API. It's a function that takes the Star Wars API path and does a fetch. Everybody knows what a fetch is. If not, it's like a simple HTTP client. If there's a problem, throw an error. Otherwise, get the JSON. Very, very simple. We've said that. Okay, and to use it, we import from starwars.js. Let's say we want to search for people named Luke. We get a Luke search, and Luke search has a results array, and the first result is obviously Luke, and I print the name. That's basically what I'm going to do for the rest of this talk, mostly. Okay, and this is Luke Skywalker, for those who don't know. He's a Jedi Knight, and Jedi Knight use the Force to do stuff. And the Force in Star Wars is like promises in Node.js. It's everywhere and has both a light and a dark side, so remember. Okay, enough talk, show me the money. Let's first use the simplest pattern, serial execution. We all use it. We await one promise, we get the Luke name, and then we get Darth Vader name and print it. And those of you who don't know, this is Darth Vader. He's Luke's father. Oops, spoiler. Anyway, sorry for those people. There are going to be a lot of spoilers today. So serial execution is boring. I'm not going to discuss it a lot. Parallel execution. So father and son bonding together. So we have Luke and Vader. And we want to. Why are we running it like first Luke and then Vader? We can get both of them at the same time and save some time. So that's what we do. First of all, no await. We just call Star Wars API, get the promise back. No await whatsoever. And then we take those promises and call promise all, passing an array to promise all and get back the searches. And promise all is interesting. It takes an array of promises and returns a promise of an array. And once we await that, we get back the array result. So we get back the array. And then we take the 0 and 1 elements, and we're done. Perfect. And shorter is we don't need promise variables, and even shorter, we use destructuring to get at the Luke search and the Vader search. And this, for me, it seems so simple, but it's really, really beautiful. We're doing parallel execution with just, one line of code. And that is the beauty of JavaScript, and that is the beauty of Node.js. It seems like so simple today, we take it as granted, but try to do this in other languages, and you'll see it's much, much, much more complex. Okay, but what if you have to do lots of things in parallel? Let's talk about that. Promise all. This is the third pattern is promise all with map. And this is the pattern I probably use the most. Let's say we have Luke, Leia, Vader, and Solo, and we want to search all of them. So this is the array of the people we want to search. And we map. We take the list of names and map it to the promises that for the Star Wars API. We just map it. We call Star Wars API for each one of them, get back a promise, and map the name to the promise. Let's see how it works. So we have an array of promises. We call map and call Star Wars on each one of those names, and we get back an array of promises. Now we call promise all, so we have an array of promises. We call promise all when we get back a promise of an array, and we await it, and we get the results. Perfect. And now print them. Easy. Okay. Oh yeah, forgot. This is Leia. She's a princess. She's also Luke's twin sister. I told you there's going to be lots of spoilers. And this is Han Solo. He's Luke's friend, and he's also in love with Leia. This is like a regular soap opera here. Okay, back to promises. Now, what's really interesting is not like we have a static array of 4 characters in Star Wars. We can use it on data. For example, Star Wars API returns all the films that Luke is in. This is the film that Luke is in, and we can use the same map to get at all the films that Luke is in one very, very, very simple call using map. So this promise all map, you see it again and again and again in code that does a lot of fetches or a lot of database queries or whatnot. I think it's beautiful. Again, so simple, and we're doing so much with just 3 lines of code. But there's a problem here. Here lie dragons. What if there were 1,000 films? Well, there aren't. There's just 9. But Disney took over Lucasfilms, so there will be 1,000 films with Luke in them. You know that, right? Most of them will be in Disney Plus and whatever. So, in 10 years, do we really want to open 1,000 connections at the same time? Remember, we're doing a map, and then we're calling the Star Wars API in parallel for all those films. That's 1,000 HTTP connections coming out from one computer. That is really, really, really bad, whichever way you look at it. We do not want to open so many connections at the same time. So what do? We use a throttling library. At Round Forest, we use Throat. I've used it previously, and it's a really nice library. There are others. We use Throat. It's proved itself over the years. First of all, we get the data, the films. Okay, we have the films. We saw that already. Now, we do the regular promise all map, right? But this will open 1,000 connections at the same time. So we pass it through Throat. Instead of giving the map a function which is film to Star Wars film, we call Throat, give it the number of concurrent connections we want, in this case 2. Okay, 2 is really small, but just for the example. And this will return a function. So if I have the original function, film to Star Wars film, Throat will return another function that is throttled. What does throttled mean? It means that if you give it all the map gives it all the promises at one time, it will go. The promises will go out 2 by 2, just like in Noah's Ark. Okay. So this is how the new function works. And again, look at that. I just added a very, very simple Throat function. That's the beauty of functional languages, and that's the beauty of the composition of promises, in that we can do a very simple change and get throttling out of the box, 0 effort, 0 time. Think of how to do that in other languages. Not as easy. Fourth promise pattern, background execution. Let's say we want to get Luke and his movies, but we want only Vader's name. Okay, it's an example, not a very good one, but it's an example. So theoretically, we can search for Vader's name for Vader in the background while we're getting Luke and his films, right? So let's do that. So let's execute Vader's search in the background. So we're calling Star Wars again with Vader, but no await, because we want this to happen in the background. So it's starting to execute, but we're not awaiting that execution. Now we do the Luke search and the film search, just like we did previously. And in the foreground, we're using await. We're waiting on the results. Okay? Meanwhile, remember, the Vader search is happening in the background. And we await it to get the Vader search promise, to get the results, and then print everything. So we've just done a background search while doing foreground a look search, then waiting for the background search to happen, and we're done. This is, again, so simple. You use it. We use it a lot at Round Forest and other places, but this is great. And it's again, I find it beautiful. But here lie dragons. I can all, where's Benji? Benji is like screaming and no, this is wrong. This is wrong. I know it's wrong, Benji. We will see what's wrong with it later. Okay, or maybe now, I don't remember. We'll see what's wrong with it, and we will fix the problem with another promise pattern. Well, actually, we'll explain what. Sorry. Now, so just a reminder on promises and rejections. Okay, promises is promise if you await it, you either get a fulfilled promise, which means the value, or if it's like a bad path and it's an error, you get a rejected promise with the error itself. You use try-catch to get at the rejected promise. If you're in .then.catch world, .then will give you the fulfilled promise, and .catch will give you the rejected error. So remember we executed Vader search in the background? And then we did stuff with Luke, and then we awaited Vader search. If an error in the Vader search happens while we're looking for Luke, the process will show a warning in older versions of Node.js, but in newer versions of Node.js, I think from 15 onward, the process crashes. So even if we do a try-catch won't help us because try-catch will catch the foreground rejections, not the background ones. So, and there's a great talk about the details of a handle promise rejection. I listened to it, I watched it while preparing this, so go ahead and see it. Great talk. So, what do? Let's talk about something else, and then we'll get back to what we do. And what I want to talk about is turning errors into results. And there are, in language land, like not JavaScript, there are two ways to handle errors. One is the JavaScript way and the Java way and the C++ way, which is exception handling. Exception handling, you do a try, you do something, and if an exception happens, you catch it. If you don't have a catch, it propagates upward in the call stack. We know that. But there's another way, which Rust and Go use. Errors as results. You call my function, and it returns both a value, and if something happened in that function, it returns an error. And then you can handle it based on whatever. And I like exceptions better because of the automatic propagation of errors. And if I don't need to handle an error, I don't want that nasty stuff. But what if I want to handle an error exactly there? That happens sometimes. I know this is a real error, and I want to recover from it, for example. For example, let's search for Luke with one method, and if that doesn't work, we'll search for Luke with another method. So I'm searching for Luke with one method. That will throw an exception. And if there's an error, I want to search for Luke with the right method. Again, it's a contrived example. Doing it with exceptions, we call Luke search, we catch the error, we call Luke search, we catch the error, etc., etc. This is like, it works, but it's iffy. I'm not a fan. Okay, try-catch is very verbose here, and I don't like verbosity. What do? I'm missing a slide here. We use a function called pResult. We've been using it a lot at Round Forest and other places. pResult is a function that gets a promise, awaits it, and if everything's fine, it returns a tuple, two values, undefined in the value, and if there's an error, it returns the error and undefined. So the first value is the error of the array, and the second value is the real value if there's no error. That's a tuple, that's what we call a result. Okay? Using it is easy. We await the star words, but we call pResult on star words. So pResult is getting the promise, and we're getting back either an error or the search results. If there's an error, we handle it, and everything's fine. So dealing with the first error, we do look error, look search. We get back whatever. If there's a look error, oh, missing a slide. If there's a look error, I handled it, etc., etc. Now, this isn't very different from try-catch. But because now we have values that we can work with, we can do interesting stuff, coolness. We do the regular same. We get back look error and look search. And now, if there's an error, we do the other one and await it and get back look error 2 and look search 2. But if there's no error, then we return the results of the previous, which is undefined and look search. This means that now look error 2, look search 2 has either the error from the first Star Wars call or the error from the second Star Wars call. And this way of handling errors, like at the moment, is much, much nicer than exception handling. And for me, it's beautiful, and you can see it everywhere in our code. It's so nice that one of our developers, who is not here at the moment for some reason, built an S result. An S result is a sync result where you give it a function, and if it throws an exception, it gives back error undefined, and if not, a result error. So you can use even, you can avoid a try-catch even in synchronous results. Okay, so we've seen p-result. How do we handle exceptions? How do we handle unhandled promise rejections with p-result? Now, this is cool. So remember, the Star Wars API is called in the background, and if an exception happens during afterwards, until we await it, we have a problem, and the process will crash in newer versions of Node.js. So this is a problem. So what do? First of all, we wrap it with p-result. Now, it's not unhandled anymore, because remember, p-result has a try-catch inside it. So it's handled. It's handled, and the result, this is the catch in p-result. It's handled now. The Star Wars promise is handled now. But this is now wrong because Vader search promise is not just the Vader search. It's an array of error or value. So what do? We destruct it. If there's an error, we throw it above or handle it for some reason. Otherwise, we console log and everybody's happy. This is much nicer. And now we've handled the problem with unhandled promise rejection. So remember, whenever you're doing a background promise and not awaiting on it, use something like p-result to help you. We can do better. The inverse of p-result is something we call unwrapped p-result. It takes a p-result promise, so the promise is a promise which has error or value. We await it and get back the error or value. And if there's an error, we throw it. Otherwise, we return the value. So we're like unwrapping the p-result and getting back just the value or throwing an error. And using it is now nice. We use the same p-result, but instead of doing the if error or whatever, we just unwrap it, and if there's an error, it will throw, and everything's fine. And if there's no error, we get a Vader search, so we avoid that if. Perfect. Again, very simple functions, working on promises, getting back results, and you have a fully function code that I hope Benji will be fine with, and I find it beautiful. So remember, handling promise rejection, you wrap it with p-result. The promise rejection is caught inside p-result, as we've seen, and no unhandled rejection. And if you want to, you can use unwrap p-result to unwrap the result. Perfect. 5 minutes. Okay. Remember this scene? So it seems that, what's his name? R2-D2 is an event emitter. When you send it a clean event, it emits. Who knows what Leia is saying here? Come on. Come on. Someone re-shout it. There we go. Help me, Obi-Wan Kenobi. You're my only hope. Right. So this is the clean event. And R2D2 is an event emitter. It's an event emitter, not an event listener. So R2D2 is an event emitter. We add a listener, and if you get a clean event, then we log, help me Obi-Wan, you're my only hope. Perfect. Let's get them to meet. R2 and Luke. So we await both promises, we get them to meet, and we emit the clean event. And it works. The console log will show, help me Obi-Wan, you're my only hope. The problem is that the rest of the Star Wars script is happening inside the event emitter. We've lost promised land, and we're back in callback land, which is a horrible, horrible land we've just escaped from in the last 5 years. So once you call back, you can never go back to nice serial await. Unless you use once. Once, and there are others, is a bridge between event emitters and promises. So once is from events in Node.js, okay? And instead of just waiting and writing it, we just await once. The await will fulfill once the clean event happens. So we're perfect, and the rest of Star Wars can happen here. Now, why am I even explaining this? That's not a pattern. That's just, a function, a great function, by the way, but it's not a pattern. Right. But, want to see some naked promises? Ooh. Let's try and implement once, and you'll see what I mean. Okay? We'll implement the once function itself. So, first try is this. We call once, okay, this is the implementation. It gets R2D2 in the event, and we add the listener, okay? And we need to wait for the event to happen, and in the listener, we need to make once return. Let's see how we can do that. I don't even know how to do this. Let's do it. How do we wait in JavaScript? We use await promise. So let's create a promise in the function and await it. So we create a promise in the beginning of the function and await it. And once the R2D2 event happens, the clean event happens, we resolve it. Perfect, right? There's just one problem. Who knows what the problem is? There's no promise resolve. It doesn't exist. Okay, it just doesn't exist. So what do? This is where we get naked. Stripping, we'll strip the promise from its resolve function. Okay? We create a promise, but we take the resolve function and put it in another variable that we do have access to. Okay, so we take the resolve function and put it outside. Now the promise is naked because we can resolve it from the outside. We await it, and once the event happens, boom, naked resolve is called, and the await ends, and we're done. Once is implemented. Beautiful, right? This is. I love this one. Last one. Last but not least. This is the most complex one. Using naked promises to implement a mutex. Okay, this is really advanced stuff. So be very happy if you understand it. If not, you can view the YouTube video until you do. So let's say we're doing a promise all, and we want to get information about person, and then console log that information, but we want get information to never run in parallel. Okay? So we want get information about a person. If I call 4 of them at the same time, I want them to happen one by one. How do we do that? The usual way. We make mutex, we create a mutex, and at the beginning, we lock the mutex. The first one that locks the mutex gets in. The second one is locked. Thank you. Second one is locked until the first one doesn't unlock, and then the second one enters, etc., until all 4 are done. This is called a mutex. So how do we implement a mutex? Let's draft it. We're returning an object which has lock and unlock. And in the lock function, if there's no lock, we create a variable with a lock. We'll see later what that means. If there's no lock, we create a lock and return, because now we're inside. We can go inside. Otherwise, and in the unlock, if there's a lock, we release it. Otherwise, if there is a lock, we wait for the lock. And when it's released, we wait again on a new lock if you want, because maybe there's somebody else that's also entered. Okay, got it. This is mind-blowing. So let's do this very, very quickly because I have 1 minute. If no lock, then I create a naked promise. Okay, we use naked resolve, etc. That means that I can unlock it by calling naked resolve. That will unlock the lock. Otherwise, to wait for the existing lock, we just await the lock. And this is mind-blowing recursive stuff. We wait again on the lock. And boom, mind-blowing async recursive promise pattern stuff. Beautiful from my point of view. So, end of the journey. Summary. So, you thought promises were simple, a toy, right? That's the beauty of JavaScript. It's simple enough language if used simply, but it has depth. And promises have depth, so go, use promise patterns, dive deep into them with all my love. Thank you very much.